today, I'm going to be looking at the concept on how to derive the deflection and the slope equation for a cantilever beam with a point load at its free end using area moment method. From our previous video, when we derived the slope equation and the deflection equation of a cantilever beam with point load at free end using double integration method, when we did that, we had our slope C to be WL squared over 2EI. When we did our slope equation for a cantilever beam, when we use double integration method, we had this formula, and our slope equation was W x to the power 3 over 3EI. So these are our formula when we use double integration method. Now we're going to be applying the concept of area moment method to also what? Derive to this formula here. So note something. Via I'm using double integration method or area moment method, I will still get the same formula. The only thing is that the process are different. When we use double integration method, the process was different. We included the web ideas, integration, all the likes. But area moment method is as simple as ABC. Now, for today, we're going to be considering how to use area moment method to derive the deflection and the slope equation for a cantilever beam with a point load at its free end. Now, first things first, I need to draw out a cantilever beam with a point load at its free end. So if I have a cantilever beam this way, having a point load at its free end this way, let me call this W kilonewton. Right? Having a point load at free end, this is a cantilever beam, right? So my deflection for this will be in this format. Take note of this. Take this serious, please. Now, my first task here is to name this part. From here, call it Wn over EI. So from this part here to this part here, call it Wn over EI. Why? Pick a center at this point. Call that center G. That is gravity. So take it upward this way. Extend this point upward this way. Now here becomes 2 over 3N. So take this also serious. When it comes to using area moment method to derive a cantilever beam with a point at free end, master this drawing. That's the concept. Just master this drawing. Where from the distance from here to here is given to be what? N. Right? So I have this. Now my first task is look for what? Area moment. You should look for the area of the bending moment. That's the first task. After I've drawn out this, look for area of bending moment. That becomes area of bending moment. Bending moment is equal to, this is a triangle, right? Apply the area of a triangle. That becomes area is equal to 1 over 2 times what? Base times height. Right? 1 over 2 times base times height. If I draw this is a triangle, right? Let me draw it this way. You can see. I turn it this way. From here to here is Wn over EI. Right? This is my base. What of my height? Is my height this or L? So from here to here is my L, not this value. So take note of this. So that becomes area. Area of bending becomes 1 over 2 times my base is what, please? Wn by 3. Wn over EI. Multiply my height, this is what? L. That becomes L. So my area of bending moment at this point. So note something, please. That area of bending moment is simply the slope. So now that becomes is equal in value to 1 times Wn times L. That becomes WL squared over over 2 times this becomes 2EI as we said initially. Now, before we start, I write the formula out. If you recall, I said C is equals to WS squared over 2EI. When we use double integration method, now you can see we use area moment method, we still have the same answer for the slope. So that is the concept behind this. Now, having gotten the slope, this is slope equation. This is slope. Sorry. For the slope equation, this is slope. Right? This is my slope. Alright, I need to get my deflection. Get my deflection. Calculating for deflection. Calculating for deflection. That becomes y is equal to area times x bar. Now listen, area times x bar. X bar means center of gravity. Think of that. Y area is simply this area here. Note that after getting your slope equation, which is area, now to get the deflection becomes what? Area times center of gravity. And center of gravity here is what? 2 over 3L. That's the concept. Now that becomes my deflection is equal to area is simply all this. WL squared over 2EI multiplying x bar is what? 2 over 3L. That becomes 2 over 3L. If I do the needful, I'll be having y is equal to WL squared times 2L. That becomes what? 2W. Let me put it here. If I proceed, y, my deflection y is equal in value to WL squared times 2L. That becomes 2WL cubed, right? 2W L squared times S cubed over 2 times 3 becomes 6. I'm left with EI. So if I reduce this, my deflection y will be equal to 2 here is 1, that's WS power 3 over 2 here is 3 EI. Here is my deflection equation. This is for deflection, and this is for my slope. So in this concept, we need just 2 things. What are what? The area moment method, the area of any moment, which is A for the slope, and what? Y for the deflection. That is all. That is the idea behind how to derive for a cantilever beam the point load at free end using area moment method. Here's all the concept here. Let's take an example and let's say we can solve the example by applying this concept to solve problem. Right, let's solve this example by applying the concept of area moment method for a cantilever beam with a point load at its free end. The question goes below. A cantilever beam of 2 meters span is subjected to a point load of 30 kilonewton at its free end. Find the slope deflection at the free end. Take EI to be 8 times 10 to the power 12 Newton per millimeter squared. My first task now is to interpret this question in form of diagram. So if I do that, I know a cantilever beam is in this format. Solution. I know a cantilever beam is in this format with a point load at its free end will be illustrated in this way. The point load is what? 30 kilonewton. 30 kilonewton. While the span is given to what? 2 meter. 2 meter. Alright. What am I given again? That's all. Right? That is all. A cantilever beam of 2 meter span 1 meter is simply the length. So my givens, number 1, I'm giving what? Span, length. That's my length. Length L is going to be what? 2 meter. Next up, is subjected to a point load of 30 kilonewton. Next up, I'm giving weight. Right? That's W to be what? 30 kilonewton. 30 kilonewton. Alright, at its free end, find the slope and deflection. Sorry, there's an and here. Find the slope and deflection at the free end. Find the slope, number 3, slope. Slope in terms of area method is what? A. In terms of double integration method becomes what? C. Take it on that, please. Number 4, find we're going to find the what? Slope and what? Deflection. We know deflection. That is what? Y. Alright. At free end, take EI. So take EI to be what? Your modulus and moment of inertia. Take it to be what? 8 times 10 to the power 12 Newton per millimeter squared. Here are all my givens. So my first task now is to ask myself, if I can solve, ask yourself, are you converting? Please take that serious, please. In physics, after listing a parameter, your next task is to check, are you converting any parametric unit? Now in this case, I am converting. Obviously I am converting, right? Because my EI here is in Newton per meter squared. So all must be expressed in terms of units. All must be expressed in terms of Newton and what? Meter squared. That's all. Millimeter squared is okay. Meter. I have to convert this to what? Millimeter. So to convert that to millimeter, simply multiply what by 1000 and have 2000 millimeter. It's off. I'm done with that. Next up, this is the Newton. I'm saying kilonewton. Convert this 30 kilonewton to Newton. That becomes what? That becomes 30,000 Newton. I've simply converted 30 kilonewton to what? To Newton. Alright, I'm done. They are all now uniform. Millimeter, it's okay. Newton, it's okay. Now, a question. If I just choose to convert this Newton back to kilonewton, am I still correct? Listen, here's the idea. This is what I'm saying. This 30 is in 30 kilonewton, right? Now, I can convert this to what? Back to kilonewton. If I choose to convert this to kilonewton back, am I correct? Yes, I'm still correct. But is it necessary? No, it is not necessary. So just convert them to Newton. That's all. That's okay. So my next task now, if I proceed, right? I'll apply my formula to solve this stuff off. Now, apply parameters, please. We said, calculate for the what? The slope. And if you recall very well, we said slope is A in terms of what? Area moment method. A is our slope, which is equal in value to WL squared over 2EI. So, am I given W? Alright, it's there. My length, it's there. 2 is constant. EI is what? Is there. I can get my slope equation. Alright, to get my slope, my slope A is equal in value to W is what? 30,000 multiply L squared. My L is what? 2000 all squared over 2, this is my 2, multiplied by EI is given to the what? 8 times 10 to the power 12. If I punch the calculator, my area, my slope equation will be alright, that is 30,000 multiplied by 2,000 to the power of 2. I will have 1.2 times 10 to the power 1.2 times 10 to the power 11 over, if I punch this denominator, 8 times 10 to the power 12 multiplied by 82, I have 1.6 times 10 to the power 13. If I divide numerator by denominator, I will have 1.2 times 10 to the power 11 divided by 1.6 times 10 to the power 13. I will have my slope equation now will be 7.5 times 10 to the power minus 3. So here is my value in radian. Please take note, it's always in radian, right? It's in radian. The SI will be in radian, right? Next up, I've gotten my slope equation. Let's get deflection, please. For deflection, we said y is equal to WL to the power 3 over 3EI. Let's get value, please. To do that, let's input parameter. Before I clean out the necessary parameter here, I have W is what, please? That's 30,000. Multiply L is 2,000. 2,000 to the power of what? 3. Yes? Over, this is 3. Multiply EI is what? 8 times 10 to the power 12. What is that? 12. Correct? Alright. Let's get deflection answer. So to get my answer for my deflection, that will simply become what is it? That will become 3,000 multiplied by this value. My y, my deflection y, is now equal to 2,000 to the power 3 multiplied by 30,000. I have, my method becomes 2.4 times 10 to the power 14 divided by, if I punch numerator, 8 times 10, denominator 10 to the power 12 multiplied by 3, I'll have 2.4 times 10 to the power 13. Right? If I divide numerator by denominator, my deflection y will now equal a value to 2.4 times 10 to the power 14 divided by 2.4 times 10 to the power 13. I have, my answer will become 1.1 times 10 to the power 27. That's my deflection formula. Deflection answer. If you have found this class helpful, kindly click on the subscription button. Also, listen. If you are new to this channel, don't forget, please click on the subscription button and like. Also, share to classmates and friends. Welcome to Wellness Link Academy.